Decarbonizing Coal-Fired Power Plant, compiled by Habib Ghifari for the final assignment of IEA GSG Summer School Geoscience. To begin with, we know that the climate change is real, and also that's why we have the Kyoto Protocol, 2009 Copenhagen, and the 2015 Paris Agreement as the international effort for climate action. The international contribution in limiting global warming to keep it below 1.5 or 2 degrees Celsius is advancing as more countries are moving away from fossil fuel. Like in the United States, although US emissions surged in 2018, but they have been declining generally over the past decade because the coal use has fallen. That is in favor for the natural gas and renewable sources. And about 28 European nations account for more than one-fifth of CO2 emissions over time, but their collective annual emissions have dropped more than 20% since 1990. Some also estimates suggest that EU is on track to meet its Paris Agreement, and the coal use is dropping, but remains a major source of the emissions. And also, it is projected that from the Paris Agreement, we could reach the zero emission based on the year 1990 in the year 2100. That is including that Asian regions are shifting away from coal in the power sector, but not for Southeast Asia. In Southeast Asia, the demand for cheap electricity is rising. Countries in these regions focus to expand their coal-fired power plant. That means it will be an obstacle in current efforts to reduce the global warming. Government money in China, Japan, South Korea is still strongly financing coal expansion in Southeast Asia. Through treasury funds or state-owned utilities, these countries have put around 24 billion US dollar for around 16 gigawatts of coal projects in Indonesia, and 16 billion US dollar for around 15 gigawatt in Vietnam, according to the coal finance tracker by Coal. From the British petroleum data of Indonesia's fossil fuel total proved reserve, coal will remain a primary energy source for more than 60 years in the future. Meanwhile, natural gas will be the transition for renewable energy development, and it is expected that Indonesia's coal capacity will be increasing until 2030, especially in the domestic market, such as power plant. But this is contrary to the current effort of greenhouse gas reduction. In Indonesia, coal contributes to CO2 gas emissions that is increasing drastically since at the first time 1985 until now. In 2019, CO2 gas emissions were dominated by coal use, which reached up to 41.2%. That is 617.5 million tons in total. On the other hand, the natural carbon reductions only occurs about 3 billion tons per year. That in here we can see that from the modeling of the carbon dioxide on Earth provided by NASA, it is concluded that it takes 5 to 7 billion tons of additional abatement annually if we want to achieve the zero emission globally. Such carbon capture, storage, and utilization will be needed in order to reach the additional abatement annually. The carbon capture or the CCS technology is one of the study processes that is still being developed to reduce the greenhouse gas emission in industry. There are various methods in CCS application such as the absorption-based cryogenic adsorption, algae, and also membranes. But among all, the monoethanol amine, or the MEA, is a CCS technology that is relatively inexpensive, commercially available, and has been widely applied in industry. Most existing commercial applications involve direct use of CO2, including the production of food and beverage, metals, fabrication, cooling, dry cleaning, healthcare, etc. And also CO2 is increasingly used to enhance yields from industrial processes, such as methanol, production of crop cultivation in greenhouses, and most applications make use of several unique properties of CO2, including its large heat absorption capacity, stable and non-reactive nature, and its ability to act as a solvent. The largest consumer of CO2 is the fertilizer industry. About 130 metric tons of CO2 are utilized each year in the urea manufacturing. Followed by the second one is the oil in the oil sector. About 70 up to 80 metric tons CO2 are used in the enhanced oil recovery. And in total, 230 metric tons CO2 are utilized each year. But let's talk about mineral carbonation. Mineral carbonation is based on reaction of CO2 with metal oxide bearing materials to form insoluble carbonates, with calcium and magnesium being the most attractive one. When CO2 reacts with metal oxides, that is indicated as MO in this reaction mechanism, the corresponding carbonate is formed and heat is released according to the following chemical reactions. And because of that, it is favorable in low temperature reactions. This could be an alternative for power plant that doesn't have any reservoir to utilize their CO2 emissions for the EOR. In example, the coal-fired power plant. From the cost comparison among the available options for CO2 storage, the mineral carbonation is the expensive one instead of geological storage. The mineral carbonation has the largest storage cost since it requires energy input about 40% of the total plant output. And also, an additional of 0.05 ton of CO2 per ton CO2 stored is emitted because of the mining, size reduction process, waste disposal, and the site restoration. But the question that arises is, what if we can modify the process and make use of the waste and lower the energy input required? The answer is the CO2 capture method by carbonation with sodium carbonate. This is a commercial method of carbonation that was proposed by Lee et al. 2019. How it works is the flue gas that is consisting of about 14% of volume of CO2 is captured in a carbonation column, and about 49.5 CO2 is converted, producing a baking soda as a useful product. This column can receive a flue gas up to 11,500 normal meter cubic per hour, and it only requires 16.6 meter cubic per hour of 13% sodium carbonate concentration solution. From the cash flow analysis, it results that indicates that the manufacturing cost of sodium bicarbonate for the baseline case is only about $0.8 per ton of sodium bicarbonate, and implementing this in a coal-fired power plant, we could achieve NPV about $2,373,000 with the internal rate of return of 18.5%. Thus, in conclusion and recommendations, even though the coal-fired power plant expansion could hamper the current effort in greenhouse gases reduction, and the CCUS can be implemented, but the problem is the geological storage is not favorable at the moment. We can use the carbonation column that uses sodium carbonate solution as a utilization method that could produce baking soda that more has added value that could generate profit. So that's my recommendations about the current situation of the coal-fired power plant expansion that is happening in Indonesia.